Welcome everybody, and thank you for joining us today for this webinar. We will be introducing the Elastic Stack and see how it can be used to power different analytics use case in telecom industry. So my name is Yassin Al-Asri, and I work as an analytics product manager at Synapticiel for the last 2 years. And I'm very happy to take you through this webinar. So just as an info, this will be the first part of a series of webinars about Elastic Stack use cases in telecom industry. Also, we will have other webinars next couple of weeks. So in case you find one of those interesting, join us. So before we get started, a couple of housekeeping items. So when you join us on Zoom, you are muted by default. So don't worry about it. You can always ask any question you want during the webinar. For that, you need just to click in the chat button as shown in the screenshot. Don't worry about taking any screenshots, as slides and recording will be shared with you at the end of this webinar. We will take 15 minutes at the end of the webinar for a Q&A session. So you can ask question anytime. You are welcome. So thanks. And let's get started. So what we are going to do today in terms of the agenda, I'm going to start with a quick introduction on why telco operator need a scalable search and analytics engine. Then I will give a quick overview of the Elastic Stack just to get you familiar with the components for those who are not. I will also share with you an example of a high-level architecture using most of Elastic Stack components. And then I will be performing a demo showing you how we can use Kibana dashboard and Elasticsearch data frames. And at the end, we will finish up with the Q&A session. So with that, I'm going to start with the introduction. So if you look at the nature of the data on stage in a telecom network, we have multiple and large sets of data coming very fast from different sources. So for example, we have complex event coming from charging and billing systems for different subscriber usage scenario, like account refilling, voice, SMS, and internet. We have also different logs coming from network management tools, especially provisioning logs and network failures. We have nowadays more financial transaction coming from different mobile money applications. And in some cases, we have signaling traces from different soft switches. So this large data mainly related to network operation and subscriber behaviors has the capability to give valuable business insights. So for example, it can help optimizing the network deployment and the point of presence footprint. It can also be analyzed for insights into real-time fraud detection, and it can also help to manage the customer lifecycle and value management with more smart pricing, promotion, churn management, credit scoring, and marketing innovation. But there is an issue actually. So the traditional data analytics system in a typical telecom deployment use today's more SQL data warehouses for storing all the network data. And there are two major issues with these architectures. So the first issue is that is more related to the scale limitation. So SQL data warehouses cannot be scaled out, means that cannot be run on many commodity hardware. We need to bring more computing capability, big server. And that's the second issue, which is the license cost. So the more the data increase, the more the CapEx and the OpEx increase. So the challenge is to process such extremely data, highly scalable and massively distributed processing system is required. And one of this system, which is open source, is the Elastic Stack. So let's talk a little bit about the Elastic Stack. So we call it a stack because it has different components, and depending on the use case, we can use all of them or several one of those. And I'm going to start with Elasticsearch, which is the core pieces of this stack. So Elasticsearch is mainly a distributed RESTful search and analytics engine. So think about it as a document-oriented database that include a powerful search and analytic engine built on the top of Lucene. On the top of the stack, we have Kibana, which is featured as the user interface for the stack. It's what lets you visualize and explore your data, as well as managing and monitoring the entire stack. And on the bottom, we have two other products that will help to ingest the data into Elasticsearch. So there is Beats, which has a data shipper. So they have a small footprint and they use fewer system resources than Logstash. And they can be deployed on server to read the data and ship it directly to Elasticsearch or to Logstash for more processing. The most important part is Logstage, which has a large footprint and provides, let's say, a broad array of plugins for collecting, enriching, transforming the data from multiple and variety of sources. So that's a high-level picture of the Elastic Stack. Now, let's see an example of a deployment architecture that can be used within a telecom operator. So this is just a high-level example. So the most important part is how the data can be ingested. So it can be ingested in different ways. So first, as I said, Elasticsearch is RESTful. So it has an API for ingesting and searching and analyzing data. So any in-house or third-party application that can ingest that data can use this API. We can have also some custom bits that can be deployed directly on different data sources, and it can ship directly the data either to Elasticsearch or Logstash. If the operator have an existing mediation system, this mediation system can distribute files directly to Logstage for processing. So, and also Logstash have the ability to stream the data directly from any queue like Kafka or Redis, and it can also stream the data from any SQL database, especially from any relational database that the BSS and OSS system use. Okay. So this is an example of a high-level anatomy of Logstage. So Logstage is a pipeline that have 3 stages. input, filters, and output. So input is used to read data from multiple sources, from files, from any queue, from file beats, from any SQL database. And it can consume the data from multiple sources at the same time. Then the data need to be transformed. So we need to normalize the data to do more lookups for enrichment, and we can do more aggregation, and especially we can do more correlations, mean that we have different sources and we need to correlate one event from different sources. We can also use many filters to do more data anonymization, especially for sensitive fields. And then the data can be outputted to mainly to Elasticsearch cluster, or it can be distributed to other systems. So that's a high level of how a Logstash pipeline works. So let's jump to the important part, is the demo. So in the case of this demo, we have a data set that has been generated randomly to simulate a medium operator, 24 hour of prepaid voice charging events. So we'll briefly show you how we can ingest data with the log stage, how we can use Kibana and data frames. So let's start. I will first show you a sample example of Logstash pipeline. So it's a configuration file that contains 3 stages. The most important stages are the input to read the data and the output to send it to Elasticsearch. Filters are optional, but they are important for data transformation. So this is an example to read data from files distributed by a mediation system. So files, they can be coming at any format, CSV, XML, JSON, binary coded, ASN1. So Logstash have a way of customizing a specific codec to read the data. We can also stream the data from Kafka, for example, from specific topics. We can also intercept data that has been sent by a custom file beat. So also beats, just to have an idea, the stack, every component has a framework to develop a custom plugin. So in Logstash, we can develop custom plugin. In beats, we can develop custom beat to read custom data format. And then events coming from the source can be enhanced. So for example, we can be transforming the date. We can be enriching with doing more lookup in a dictionary to make the data more relevant. We can also remove any unnecessary field to clean the data. And then we can output the data to an Elastic cluster or multiple Elastic cluster. And we can specify the destination. So it's a distributed system with huge volume. So we can partition data on a time basis. It can be on a daily basis, weekly, monthly, or hourly if you want. We'll show you an example of pipelines. So this is an example of pipeline, or let's say a configuration of Logstash. We can call multiple pipeline at the same time. So I can call the configuration here and specify how many workers that need to be used for this specific pipeline. Here, for example, I want to use 4 processor to run this pipeline. I can also say, yeah, for this pipeline, I have more files coming. I want to use more processor. So it's really, it can be really horizontally scaled. So let's see how the data is in Elasticsearch. So this is the UI Kibana. It's secured. I can get access and see how the data is ingested. So as I said, Kibana is the user interface for discovery, visualization, dashboarding, sharing dashboard, but it's also the UI for monitoring and managing the entire stack. So I can go here, for example, and see how many data store I have. So the example I show you is a configuration where I ask to send data to a daily basis indices. So here I have a 24-hour data set, and I see 2 indices created automatically based on the event timestamp. So, and I can see how many primary and replicate charts. So behind is Lucene, and Lucene is using a data container called shard. So on every index, I can have multiple shards. And for every shard, I can have multiple replicates. So this is something for the high availability. And I can see how many document is stored on each index and the size used for each indices. A document is an event, and the document is stored as in a JSON format. Okay, so here let's discover the data that has been ingested. Okay, so this is the indices where I ingested the data. I can go back for the period that I have ingested, and I can see the data coming here. And I will show you that it's a JSON document. So for example, this is a voice charging event coming from, I guess, Huawei or Ericsson charging. So I can see a caller, a subscriber calling another subscriber, and the event get charged with this amount. And this is the user duration, the rated duration. This is, for example, a 1 minute based rating. And I can see different balances that has been charged. For example, I can see that this event has been charged from the main prepaid balance. So I can, for example, show you an example of query that has been saved. So the data can be organized in a friendly way in a table where I can show for every timestamp, the event type, the caller and the caller, the user duration, the charging amount, and the balance that has been impacted. So, and I can have multiple filters, for example, and I can see service flow. I can see if there is any roaming record here, for example. I have some mobile terminated events. Prepaid means the subscriber was in a roaming position. So I can see different event here, for example. So this is one of the power feature of Elasticsearch is a search engine. Then I will show you why we call it an analytics engine. So on every search query, I can do multiple aggregation. This is the screen will be coming here. So I can create a visualization. We have different type of visualization, like area, table, gauge, heart map, matrix, pie, and so on. We have also maps representation that I will show you. So I can see a quick, for example, a table, and I can go and visualize the data from a search query that I have saved, or I can go directly to the entire indices and see what happened. Okay, so here I can specify the metrics that I want to compute. I have different, the average, the count, the sum, and different advanced metrics. So let's see the sum, how many, let's see how much the revenue has been generated. Okay, this is the revenue. I want also to see how many active subscribers that has been generate this revenue. So I can do a unique count of subscriber. Served MS is then. So those are the metrics. Then I can choose to have many different buckets. Means that I want to group metrics by different level. Let's say I want to see the revenue and the number of subscribers generated by rate plan, for example. You can specify the rate plan. And I want to order by the revenue. I want to see the top 50 rate plan, and I can specify a rate plan. Okay. I can add different dimension splitting also, and I can click and get the result. I can choose to show the sum, for example. So I can see easily for every rate plan, the total amount of revenue generated and the number of subscribers belonging to this rate plan and generating this amount of revenue. So here the revenue is a metric that has been computed at the ingest time, because we have every event have different balances that has been impacted. But depending on the use case and the definition of the revenue, most of the time the revenue is the amount debited from the main balance. So we may see together how many, what is the percentage of events generating the revenue and the percentage of events that are not generating the revenue. So I can save this example. Okay. So I can add many visualization as I want. Then I can choose to group multiple visualization in one dashboard. So I can add them to an existing dashboard or create a new dashboard. So I will use an existing dashboard and just show you how I can add this visualization to this table. So I can choose to edit and add. And here I have the list of the visualization. I will be choosing the table, the searching demo. demo, yeah, this one. So it will be added here. So you can see, I can drop it on the top. Okay, and add it somewhere here. So it can fit the dimensions up. Okay, so this is a table that has been added to an existing dashboard, and then I can save it. And I can share it easily, for example. So I can export it as a image or a PDF, or I can share the permanent link that can be embedded in another third-party application. So I can generate an application. So the importance of Kibana dashboard, that is more interactive, and it can be refreshed on the flight, means that the data is ingested, and most of visualization are aggregation from the raw data. So the dashboard can be refreshed automatically. So can I specify here, for example, so let's refresh on every 10 seconds. And it can be refreshed. So here, for example, it prompts me that I can download the report. Okay. So this is an export example. And there are more advanced features that we can see later in different webinars, that I can create a job using Watcher that can share automatically on every day, sending a dashboard in emails. Okay, here I see the dashboard is getting refreshed automatically. So this is a way of using Kibana dashboard to see what happened in real time. And it's more interactive. So I can filter, for example, this rate plan and see what. So I can have a filter based on this rate plan. So when I choose it here, it will add automatically a filter on the top of the dashboard, and all the data will be filtered. And I can go back. I will see that the data will be again refreshed. Okay. And there are more advanced features for data visualization, especially maps. So maps can be used to describe and see geographically how the data will be dispatched. So here, for example, at the ingest time, we have enriched the data with all the towers, latitude and longitude information. So we can be able to display the data on a map. So I can compute, for example, multiple metric for every tower. So here, for example, I'm seeing how much revenue generated by every tower, and I can see, for example, what is the minimum and the maximum, the average, and how many events, for example, has been generated by this tower, and I can save. So I can zoom in and zoom out and see every tower, how much revenue has been generated. So this is very useful from the operations perspective, to see what are the towers that generating more revenue and what are the towers that having more subscribers localized, and to give more maintenance operation to this part. So this is a way of combining technical metrics with business metrics, and to put more focus on towers that generate more revenue than putting more focus on tower that generating less revenue. So the same can be used from the sales perspective, for example. So for sales department or marketing department, maybe they are not interested to see on a tower database. So they can see for every territory how much revenue being used. So if we have, let's say, a geo shopping of the region, we can import it directly to Elasticsearch and have multiple aggregations. So the same here, I can see for every territory, I can add multiple metrics, for example. And I can see and I can visualize them directly. Close, and I can see here for every territory the revenue and the number of events, number of subscribers, and so on. So I can have different metrics for every region. So if we have a shop of the territory, we can divide into multiple sales territory and see what happened on every region. So globally, this is how Kibana is used for dashboarding, and the most important is that the dashboard get refreshed directly from the raw data. So now we'll show you another feature that is very helpful, especially for people that are very interested by machine learning for outliers detection, churn management, or subscriber behavior classification. So it's hard to do analysis directly from raw data. So we need to compute different metrics for every subscriber, and also for a retention and storage constraint. If you want to analyze, for example, a long period of retention, let's say 2, 3, 5 years, it's very hard to get the dashboard refreshed directly from the raw data. So it's useful to have features that can help to summarize the data, and especially on the fly, means that on real time. So I will show you a new feature that has been released in 7.3. It's still in beta version. We call it data frames. And data frames, it allows to create a data-centric index, mainly entity-centric index. So I will show you an example. I want to see, let's say I want to compute different metrics for every subscriber. And from fraud detection perspective, let's take, for example, they want to see what happened if I have high usage subscriber, if I have probably SIM-box subscriber. So let's compute, oh, what happened? Served, I want to see for every subscriber, served MSUSDN. I want to see the main revenue. This is just to have a nice names, the main revenue. And I want the user duration. And I want the rated duration, for example. No, not this one. Rated duration, I'm mainly interested in this one. Yeah, this one from the charging. And let's say I want to see how many called party. For this, I will use the cardinality aggregation. And I want to see how many cell that has been visited. So I always use the cardinality of cell ID. I want to see also how many IMSI has been used, just to see if there are subscribers that using a lot of SIM swap. IMSI. And I want to see how many, to see just how many call. So the cardinality of the identifier. So let's just get nice names. And this one also, rated duration. Let's say this is the called parties count. Let's say this is how many visited towers. Let's say this is a number of SIM. And let's say this is events count. Okay. So here on the right, I see a preview for every subscriber. So I can see that how many called party, how many event, what's the main revenue generated, the rated duration, how many SIM, and the user duration, and how many visited towers. Okay, so from for a machine learning process, it's better to add a time-based dimension. So mainly we can choose a window of, let's say, every 1 minute or every 1 hour. But for the data set I have here, we don't need to have, I have just 24-hour data set. So just to get a quick demonstration, I can see next. I can give an ID. I can give a description. And the most important is a destination index where computed data will be stored. So we'll call it subscribers fraud metrics. And the most important that I have an option is to be on continuous mode. Means that I can create a data transform that can be run on demand, but the most important that it should be continuous mode every 10 seconds, every 1 minute, and so. So I can say next, ops, create and start. Okay, so here I can see that my transform is running. I can see a brief summary, how many document has been processed and how many subscriber has been detected and metrics that has been computed. So I can go back to the management interface and I can see that I have a new index called subscribers metrics that it's going up. Let's visualize what we have in this index. So I have to choose it here. Okay, and I see that I have different metrics that has been computed for every subscriber. So for this one, he's using one SIM. He has visited 5 towers for 5 events, and he called 5 numbers, and he used 2 minutes to 2.5 minutes, and he generated 0 revenue. Means that he's using different free balances like bonus or something like that. Okay, so I can show this metrics in a friendly table. Like that. So I can see for every subscriber, I have different metrics. So I can order them just to get some insights. Wow, so I see this subscriber is making 79 outgoing call to 75 called party, but is visiting more towers, means that he is in mobility, maybe a VIP customer or something else. So, but this one, for example, has made in 38 call to 38 subscriber, but he's just visiting 2 towers, means maybe he is in the same place. So this is a way of, so I can see that the data is getting refreshed automatically. Yeah, I can see 197,500 subscriber and so on and so on. So this is the continuous, this was the continuous mode of the data frame. So as the data is coming to this index, so I can go to visualization and create directly visualization from this aggregated index and embed them into a dashboard. So it's a really interesting way of getting insights. And this summary data can be used in machine learning. So just for information, Elasticstack have 2 other module, machine learning and graph for analytic. Have also a security solution and other applications that we can see them in next webinar. So just a last information, I can show you that Kibana can be also used for monitoring the stack. So we can see what really happened on the stack. So I can see that I have an Elasticsearch cluster that have only 1 node, and this node, how many storage available, how many memory has been used, what's the version, and how many indices, how many events or document is being stored in the cluster, what's the total storage, and so I can go inside and see different nodes, the processor load, the average memory used, and I can see the data stores indices on every indices, how much document I have, what is the indexing rate, for example. I have a data transform is running and indexing record here, so I can see the speed of rate of ingesting data, the speed of searching, And if there is any unsigned shard or replica, I can get warning. So this is the whole picture of how Kibana can be used. So also Kibana can provide the ability of developing custom plugins inside Kibana. So for example, we can add different control to see different alerts. We can add a new application inside Kibana. This is a way that can help and getting all necessary information, operations, process in the same friendly user interface. So that's all. So hope it's interesting, and let's see if you have any question. You are welcome. So you can use just the chat, and you can ask question here. And I will be giving answer, giving more demonstrations. So feel free to ask any question you want. I'm here to give you answers. So we have some question. So the first question is a question related to security. Is the stack secured? Okay. security, let me show you a slide where I can explain that. Maybe this one, yeah. So from the security perspective, the Elastic stack, so starting the version 7.1 and 6.8, it provides security for free. Means security, there are 3 levels of security. So first is the encryption. So Elasticsearch is distributed, means we can have multiple nodes. So nodes, they are communicating between them using transport protocol. So communication can be encrypted using SSL or TLS. Also, Kibana, Logstash, and other third-party application, they communicate with Elasticsearch using REST API. So also the HTTP communication can be encrypted. So, and this is for free actually in Elasticsearch. It provides also authentication, mainly, especially simple authentication. That means I can secure access to all the component of the stack. For more advanced security integration like Active Directory, LDAP, single sign-on, we need annual subscription with the license to get access to commercial features. But authentication, simple authentication is free. And we have a third level is the authorization. So we can define role-based permission to access the feature of monitoring and managing the stack. And the most important that we can define permission to access the data. So I can define permission to access a specific index and to access to a specific fields and restrict other fields. So for example, if you want to provide access to the call center to troubleshoot customer complaints, so you can restrict sensitive fields. You can also restrict sensitive documents, means that if you have some VIP customer, you can filter. I can create a role that no one can see events of these VIP customer. The second question, you don't use any database to do this. So the database is mainly Elasticsearch. So it's a NoSQL database, document oriented. So it's the database used behind is Elasticsearch. So Elasticsearch can store, search, and analyze the data that has been stored. And the data is stored in a form of documents. So every event, every record, every CDR is a JSON document that is stored in Elasticsearch. The other question, in which telecom provider is this deployed and what are the most common feedbacks received? So for the moment, we have 2 use cases that we have successfully deployed, and mostly in, so one in a mobile network operator in West Africa, and the use case is more related to business intelligence requirements. So we have deployed the entire Elastic stack to ingest most of network elements, CDR, and to create operational and executive dashboard to see what happened. So we are ingesting mostly around 60 million CDR every day. And we have developed multiple dashboards regarding the income, amount of refill, revenue for every services, voice, SMS, data, transaction related to mobile money, transaction in local and roaming, and computing the active park, computing the churn subscriber. This is just for automate the dashboard to be communicated to the regulator for legal compliance. So the second use case that we are working on is for a global telecom carrier in West Africa that provide mobile, landline, fiber to the home, DSL, and the use case is more related to revenue assurance. They have a big issue, and they have a lot of discrepancies between switches and billing. So we are collecting multiple dump from billing from the network using log stage, and we are doing real-time correlation to detect discrepancies. And we have developed inside Kibana application for processing all the anomalies that has been detected, and behind create a dashboard to see if to track how things are going to evaluate. So another question, we have generally many file format in telecom system, ISN1 binary. How do you decode each source file? So as I said, log stage has around 200 plugins, and it can read most of the usual format like CSV, JSON, XML, and so on. But for a specific telecom format, mainly the binary and ISN1, we develop custom plugin to read the data. So as I show you here in this example, here for example, we are processing files coming from Ericsson's charging system, and they are coming in the ISN1 format. So for that, we don't have an existing plugin with the Logstash community. So we have developed our own codec to get the full events from the ISN, and then we filter and we enrich them to do that. But if you have an existing mediation system, it can do the job and deliver JSON or CSV or XML file to Logstash to do that. We can do the same thing with beats. We can develop custom file beat to do this job, but beats are mostly used to be deployed remotely to multiple data sources, which is something that is not allowed with telecom operator. So mostly the data are collected from the switches and processed in a server side. That's why mostly we use Logstage. And Logstage we can use either Java or Ruby as a programming language to develop custom plugins. So how do you integrate with the billing solution vendor system, cloud on-site installation? So it Elastic Stack can be deployed on premise. It can also be deployed on cloud. I'm trying to understand the question. How do you integrate with the billing solution vendor system? How do you integrate? I'm not sure if I understand the question, but mostly we are in a big data solution that can stream data from multiple sources. So, for example, billing solution, if they can generate or dump the data in files, they can be collected, ingested. If they have open interface API where we can stream the data, it's possible also with Logstash. If they have any relational database, so Logstash have standard plugins to stream the data using JDBC driver. So we can read directly any data from any table, from any SQL query. We can stream the data directly to Elasticsearch. Then behind in Elasticsearch, we can create dashboard. We can search very quickly. We can create machine learning job. We can get insights. So maybe other solution like billing, CRM, they need to get the data. So there is the RESTful API. So any billing, any CRM solution, they can look up into the data directly with the API RESTful. So this is mostly useful when you have a use case where a customer call the call center to complain that, yeah, I bought a bundle, but I didn't get the services. So you can search quickly data in 6 month retention, 1 year, 2 years, very quickly, and get the response and display it in a CRM interface. So there are a lot of use cases of integration on that. So hopefully I give you the answer. So another question, in fraud management, can you disable an MSUSDN from HLR if some abnormal events are detected? The response is yes, that is something we do. So the use case I presented for you here, let me show you. So this is a plugin. This is one of our products that we have developed inside Kibana, for example. So it's doing a lot of data correlation to detect anomalies. So let's, for example, see that this is a case related to discrepancy. Let's see this, for example. So this is a mobile postpaid lines with international call in AHLR, but not in billing system. So this is, for example, a list of outliers that have an issue. And so it's easy from inside this product to call an outside microservices or sending a request to the billing or the provisioning system and asking for an action. Yeah, let's deactivate all these lines on the HLL directly. So the same process we are working on to use it in mainly in SIM swap or fraud cases. So we can imagine actionable transaction that need to be sent directly to a network element or a provisioning system and ask for an action. So it's completely possible. So there's other questions. So is it possible to carry out provisioning on this by initialization, activating or stop? Yeah, of course. We have another product which is mainly specific to provisioning operation, and this product have multiple microservices that can be called with the RESTful API. So we can send a request to this product or to any existing provisioning system or billing system that provide API. We can send request and ask for an action. Yeah. This is something we do usually, yeah. In revenue assurance, this is another question, revenue assurance question. Do you correlate the OCS data and MSC, for example? Yeah, yes, this is something that we do at the ingest time. I will just show you an example. So I will go back to discovery. And see the events coming from the charging systems. And in every event, there is what we call a core reference number. This is for Huawei OCS 5.5. And in Ericsson charging node, we call it, the correlation reference number. So this is the number that we find in every, we find it in the mobile, the MSS, the mobile soft switch. On every CDR generated by the mobile soft switch, there is a core reference number. And when the MSA trigger the charging system or any other system, it shares this reference. So on CDR generated by the charging system, we have also this reference. So in log stage, there is a filter called aggregate. And the main role of this filter is to correlate the two events, the one coming from MSC and the one coming from the charging system, and group them in one event. So in one event, we have parameters related to MSC and parameters related to charging. So we can compare, for example, let's say the MSC has been generated the event, but the OCS has not been generated the event, and so on. So this is the same logic we use for correlating network element dumps with the billing dump. So we get, for example, a dump from the OCS, from the HSS, and we get the dump from the billing. and the three dumps are correlated into the same index. And for every subscriber, for one document, we have all the parameters related to HLR, HSS, PCRF, billing, and OCS. And then we run analysis to see, yeah, in billing, he have roaming service, but in HLR, they don't have the roaming service. So that help us to raise anomaly. Okay, second, another question. What protocols do you use to integrate with the HLR and billing? It's depend. So for example, Huawei OCS, they provide SOP web services. So we use XML over HTTP to communicate with the charging system. So most of AHLR or HSS system, they provide MML interface. So we can interact directly with MML interface and send a request, wait for responses. Billing, some billing system, they provide IPI. Modern billing system, they provide RESTful IPI. Legacy, they provide XML SOAP API. That's something that we use. And there are other billing systems that they provide only batch interface, where we need to generate a file and put it in an FTP, and it will be processed, and we come back and check the log. So those are all protocols that we can use to integrate with different network elements and billing systems. We use, for example, we had a use case where we need to have some actions directly on network element related to fiber to the home or XDSL. So we need to interact directly with the MSAN, DSLAM, and for that, either we use the NMS interface provided, which is mostly XML over HTTP or MML. And in some case, we use directly SNMP protocol to communicate with network elements. I can still be here if you have any other questions or any other feature you want to ask about it. Anyway, next few couple of weeks, I will be sending you information about next webinars. I will be showing more use cases. I will be also tomorrow or next week sharing with you the recording and the slides for this webinar. So I will be here also for maybe 10 minutes if you have other questions. I think it will be okay for today. So thank you for your time, and hopefully it was interesting and you were able to have an idea about the Elastic Stack. Thank you so much and see you next time. Thank you.